Hello, good people. This is Trockers. Welcome back. Okay, so today we need to tackle a problem on complex numbers. It's from ZIMSEC, June 2013. The question reads, Part A, using the substitution W is equal to Z to the fourth power, solve the equation Z to the 8 minus Z to the fourth minus 6 equal to 0, where Z is a complex number. Part B, the real part of the complex number, Z plus 2 over Z minus 2, is 0. Show that the locus of the point representing Z in the argand plane is a circle with center 0, 0 and radius 2. Then part C, we need to sketch in an argand diagram the set of points representing all complex numbers Z, satisfying both the inequalities, the absolute value of Z minus 3 minus I is less or equal to 4, and pi over 3 is less or equal to arg Z minus 4 minus 2I less or equal to pi over 2. Right, so guys, first things first, we need to make that substitution, and you're going to see that it's going to be an equation in, it's going to be a quadratic equation. Right, then from there, we are going to play around with the substitution, and we'll find, we're going to use the formula for solving the, finding the nth roots of what? Of complex numbers. So let's talk about that a bit before we delve deeper into this. Right, so guys, we need to understand that a complex number can be represented in several ways, but I'm going to talk about the three main ways. Like we have, which is the standard form or the rectangular form, where we are going to, where we just express it in the form a plus ib, right, or x plus iy, right? That's the first way. Or we can express it in Euler or in exponential form, where we say z is equal, z is already there, so z equal to r e to the I theta, right? And in polar form, where we say it's r, then cos theta plus I sine theta, right? So these are all ways of expressing complex numbers, right? So guys, I'm going to dwell much on the last one, which is the polar form, because that's where we are going to derive the formula from, right? So we know that if we are given this formula here, okay, so we know that Z is equal to R cos theta plus I sine theta. So when we are dealing with trigonometric functions, we still get the same value if we keep adding multiples of 360 or 2 pi. So here I can convince you by saying this is the same as rewriting this as cos theta plus just say 2k pi. Remember, 2 pi is just 360 degrees, though it's 2 pi is in radians, right? Plus I sine theta plus 2k pi, right? So k, we take values from 0, 1, 2, 3, and so on. Okay, so here we are going to generate the same solution. So for example, if my theta is 30 degrees, we know that sine theta is 0.5. So if I add 360 to theta, I'm going to get 390. And if you find sine 390, again, I'm going to get 0.5. We'll get the same y value, right? From there, if you add 720, you're going to get 750. And if you do sine 750, you're going to get the same value, right? Now, let's pause here. Then I'll take you back to the De Moivre's theorem, where we know that if Z is equal to R, then cos theta plus I sine theta, then Z to the n is equal to R, then cos theta plus I sine theta, right? That's my I here, all being raised to the power of n. But R is going to be affected directly by this exponent. Now, the De Moivre's theorem here, it just affects the angle. So I'm going to multiply here plus I sine, then n theta. So this exponent will come and affect the angle here, our argument. Is it making sense? Okay, so now that I have talked about this, let's see how we are going to apply the de Moivre's theorem to come up with the required formula which we are going to use to solve or to generate solutions for complex numbers. Right, so maybe if z equal to z equal to n is equal to that, if you want to solve this equation, theta plus 2k pi plus I sine theta plus 2k pi, right? Remember, you can also use degrees, but I prefer to use radians in this case, unless the exam states otherwise. So when I'm solving this, you will see that z is equal to r, right? Then this is cos theta plus 2k pi plus I sine theta plus 2k pi, all being raised to the power of 1 over n, right? Because I just take the inverse operation of that exponent there. Like what I've said, r is affected directly, right? So it will be nth root of r. Remember, 1 over n from your indices, 1 over n, right? X to the 1 over n is same as saying nth root of x from the rules of exponents here, right? So now, at this point, it becomes cos theta plus 2k pi, then you're going to divide by n. Remember, I said this exponent will affect the argument, our angle. So since it's 1 over n, it becomes the denominator there, plus I sine theta plus 2k pi over n, right? So this is the formula which we are going to use, right? This is the formula that we need, this one. Or you can, and in this case, our k is equal to 0, 1, 2, 3, up to n minus 1. N is the degree or the highest exponent for that complex number. So for example, if it's z to the 4, our n will be 4, right? And remember, when I say z to the 4, it means we are solving that complex number and we need to come up with 4 solutions. If it's z to the 10, we need 10 solutions. If it's z to the 8, we need 8 solutions, right? And now you can write this in exponential form and say it's just nth root of r, then it's now e to the I, then our theta is theta plus 2k pi over n. So you can still generate the same solution using this, either of those forms. Okay, so that being said now, guys, I think I need to move this up. Okay, so now let's go straight to our question. So from our question, we were told that using the substitution, w is equal to z to the 4. So we are going to use w equal to z to the 4th power, right? Solve the equation z to the 8 minus z to the 4th minus 6 equal to 0. And it is 10 points, right? So these are small issues, guys. Here, this is the same as saying z to the 4th being raised to the 2nd power minus z to the 4th minus 6 equal to 0. So we are going to let z to the 4th be equal to w, right? Hence we have our equation w squared minus w 3 was 6 minus 6 equal to 0. So we need factors of -6 which sum to -1. So these two factors are -3 and +2. So we now have w minus 3 and w plus 2 equal to 0, right? So when we solve there, our w equal to 3 or -2. But remember, w is equal to z to the 4. So now this implies that z to the 4 is equal to 3 or z to the 4 is equal to -2. Now we need to solve this. And remember, we have been told that z is a complex number. So don't just go and do the direct method of just taking the fourth root on both sides and think it's okay. No. So we remember, for each complex number, we need to identify the argument. We need to find the modulus, right? So in this case, what we are going to do here, let's see. So for every complex number, one thing that you need to know is that if a complex number lies on the positive x here, right? So maybe if it's just 3, right, here, it means your modulus will be 3, but your argument here, it will be 0. Anything on the positive x-axis, the argument is 0. If it's maybe 3i here, right, it means your modulus, in this case, it will be 3. But your angle now, it will be pi over 2. That's 90 degrees. Remember, angles are positive when you go anti-clockwise, right? Then, when it's here, maybe we have -3. Still, our modulus will be 3, but the argument now is pi, 180 degrees, because it's from here to there. Here it was just from here to there, which is 90 degrees, right? Then, when it's here, say we have -3i, still our argument will be 3, but our modulus, but the argument now is -pi over 2. Here, I know you were going to say 3 pi over 2, which is 370. This is mathematically correct. But remember, the principal argument of a complex number lies within the range from -pi to pi. Hence, when I'm going clockwise, I'll just take the negative angles, right? And we know that in these quadrants, if an angle is here, it's just a theta. Here it's just 180 minus theta. Here is the negative of that. 180 minus theta, or simply theta minus 180. Then here is the negative of whatever theta. And we know that theta is coming from this. Our theta, it will be just arctan of y over x, when our complex number is given in the form x plus yi, right? You just divide the y value here and the x value. So that's how we find our theta. So once we get our theta and we identify the quadrant in which that angle lies, then that's when we are going to apply these and to get the respective what? To get the respective arguments. But if it's on the axis, that's where you choose 0, pi over 2, pi, and -pi over 2. Right, so now let's go back to our question. Right, so coming back to our question, we had that was z to the 4 is equal to 3 and z to the 4 is equal to -2. Okay, so allow me to write it here. Z to the 4 is equal to 3. Then I also have z to the 4 is equal to -2, right? So from here, what we are going to get is that first I need the angle here and I need the what? The argument. So my r here is 3, but my argument here is 0 because this is +3, which lies on what? So +3 is here. So we know that that's my argument, that's my modulus, and the argument is just 0. Then for this one, our since it's -2, -2 is here, right? So it means my r is equal to be 2, is going to be 2, but my theta is going to be pi, right? This is pi, right? So once we do this, then we are home and dry. So that being said now, so I'll start with 3, then we generate the solutions, then from there we move on to the other one. So let's start with 3. So z to the 4 is equal to 3, right? Z to the 4 is equal to 3. Okay, so when I start with z to the 4th is equal to 3, remember this, our formula, z is equal to nth root of r, then this was cos theta plus 2k pi over n plus I sine theta plus 2k pi over n, right? This is the formula which we are using. So here, my r is 3, so it's gonna be, okay, let me get rid of this. So it's gonna be z is equal to 4th root of 3, then this is cos, right? Since my theta is 0, it's just going to be 2k pi over 4 plus I sine 2k pi over 4, right? So here I think I'm going to express it to two significant figures, right? So now guys, we are starting to generate. So remember I said k is equal to 0, 1, 2, up to n minus 1, which is 4 minus 1 up to 3. So we're going to generate 4 when k is 0, k is 1, k is 2, k is 3. Then we have those 4 solutions. We move on to the other one, we do the same. We have 4 additional, and in total it becomes what? 8. Remember, it was an equation in z to the 8, meaning to say we need 8 solutions. Right, so now I will start when, let's start when z is equal to 1. So z when k is equal to 0, right? So when k is 0, here it's going to be what? What is cos 0? Okay. So am I in gradients? Yes. So cos 0 here is just 1. So it's going to be 4th root of 3. Then here it's 1 plus sine 0 is 0. So the answer will be 4th root. So that's 4th root of 3. So it's 1.31. So I'm getting 1.32 plus 0. So the first one when k is 0, we got 1.32. Then we move on when k is 1. So when k is 1, we are going to get 4th root. Then here it's going to be cos, right? 2 pi over 4 is just pi over 2 plus I sine pi over 2, right? Okay, so it's 4th root of 3. So let's see, cos 90 should be it should be -1. Okay, cos pi over 2, cos pi over 2. Okay, so cos pi over 2 is 0. Then sine pi over 2. So if it's sine, it's 1. So plus I. So I think we've done it here. So the answer will just be 1.32 I. Right. So we got this. Now let's see when k is 2. So z for k is equal to 2. So when k is 2, it's going to be 4th root of 3. Then here it's just cos, when it's 2, if I put 2 here, 4 pi over 4 is just pi plus I sine pi, right? So now it's 4th root of 3. Then let's see, cos 180. So cos pi, that's -1. Sine pi is 0, right? So here the answer will be -1.32. And it does make sense. As you can see, you see, we have the same what? The same modulus there. Then lastly, when k is 3, right? Here it's 4th root of 3. Then it's gonna be cos plus I sine. So let's see, if I put 3, 2 times 3, that's 6. So just allow me to say 6 pi over 4. Don't worry about simplifying here. Okay, I know it will be 3 pi over 2. So cos 6 pi over 4, that's 0. So here it's 4 cube root, then it's 0. I believe this is going to be -1. Let's just confirm. So if it's sine, that's -1, yes. So your answer there will be -1.32 I. So guys, we are done for the first part, right? When for the first part, when z to the 4th power was 3, so we generated these 4 solutions here. We generated these 4 solutions, which is 1.32, -1.32, 1.32 I, and -1.32 I. Those are the 4 solutions. Now we are moving on to this one. We already know that our theta there is pi, so z to the 4 is equal to -2. So let's go and solve that, right? Okay, so we want to solve z to the 4th power is equal to -2. Remember our formula is gonna be z is equal to nth root of r, right? It's nth root of r, then it's cos theta plus 2k pi over n plus I sine. So you see what I'm doing right now, I've memorized this. So candidates, you are supposed to know this. You are supposed to memorize this. We need this to generate the solutions, right? So here, so our z, it will be, since our modulus is 2, so it's gonna be 4th root of 2, right? Then our angle now is pi plus 2k pi over 4 plus I sine pi plus 2k pi over 4, right? Then our k will be 0, 1, 2, and 3. So as usual, we start when k is 0, right? So when k is 0, it's gonna be 4th root of 2, then this is cos pi over 4 plus I sine pi over 4, right? So it's cos pi over 4 plus I sine pi over 4, should be 1.4 something something. Okay, so cos pi over 4, okay? Cos pi over 4, it's root 2 of 2. Okay, allow me just to use this. So it's gonna be 4th root of 2. Then here, I can just use the exact value, root 2 over 2. Then cos pi over 4 is the same as pi, sine pi over 4, right? So plus I sine root 2 over 2. So not sine, no longer have sine here. Plus I, or plus root 2 over 2I, right? So this is the first one. I'm going to leave this in exact form, right? So we are done with the first one. Now let's move on to the other one. I know we can take out the 2, then from there we divide. Oh, let's just do that. Let's just do that. Okay, so here we can write this as 2 to the 1 over 4, right? But if we take out the 2, we are going to divide. No, guys, let's leave it like that. Why do we need to complicate our lives? So just leave it like this. Then let's see z when k is 1. So when k is 1, it's gonna be 4th root of 2. Then this is cos pi over 4. So when k is 1, this is 2 plus that. So it's 3 pi over 4 plus I sine 3 pi over 4, right? So if I get 3 pi over 4, for sine it's root 2. So it's 4th root of 2. Here it's plus root 2 over 2i. What about for cos? It's negative, so negative root 2 over 2. Right, so we are done with this one. Let's move on and see when k is 3. K is 2, I mean. Right, so when k is 2, for k equal to 2, it's gonna be 4th root of 2. So here, 2 times 2 is 4, plus 1 is 5. So it's cos 5 pi over 4 plus I sine 5 pi over 4. So what do we get? 4th root of 2, right? So it's now 5 pi. So for cos, it's negative root 2 over 2. Then for sine, it's negative again, negative root 2 over 2i, right? So we are done. Now, last one, when k is 3. So for k equal to 3, again, it's 4th root of 2, right? So it's going to be cos something plus I sine something. So if we increase 3, 2 times 3 is 6 plus that. So it's 7 pi over 4. 7 pi over 4, which is 4th root of 2. Then this plus that. Okay, so let me change that to 7. So for sine, it's going to be negative root 2 over 2i. I believe this one is going to be positive. Let's see when it's cos. Yes, right. So again, we have generated another set of what? Complex numbers. If you want, you can simplify this further and express in decimals, but make sure you leave your answers to 2 significant figures. But in this case, the question was just silent. So I prefer to leave it like that. So at the end of the day, guys, we have 8 solutions. 4 here for when z to the 4 was negative 2. And we also generated these 4 when when z to the 4 was 3. So here you could also leave it in exact form like cube root of 3i, or like what it did. It's still mathematically correct, right? So guys, we are done with the first part of the question, and we have scooped all the 10 points. Now let's move on to part B of the question. So part B of the question, it reads the real part of the complex number. So we are told that z plus 2 over z minus 2. We are told that the real part is 0, right? But do we know the real part? No. So first we need to identify the real part for this complex number. So we are going to let z equal to x plus iy. So what it means is that we have x plus iy plus 2 over x plus iy minus 2. So I'm going to combine the real parts together, right? Plus iy over x plus, it's now x minus 2. So x minus 2 plus iy. Then here I can rationalize, right? I just want to rationalize from there, okay? So when I rationalize, I'm going to multiply top and bottom by this, which is x minus 2, then minus iy, x minus 2 minus iy. Right, so let's simplify. So when simplifying, it's going to be this times that. So it's going to be x plus 2, x minus 2, right? Then minus iy x plus 2 plus iy x minus 2. Then this and that minus I squared y squared. Remember, I squared is negative 1, but for this one, just use the difference of squares. For complex numbers, it's just plus y squared. Right, so we're going to keep it like that. Okay, so when we simplify that further, this is the difference of squares, so it's just x squared minus 4, right? Then minus xyi minus 2yi, then plus xyi minus 2yi, then minus I squared y squared, right? All over x minus 2 squared plus y squared, right? Then this and that goes to hell, and we have we are left with x squared minus 4. Here negative 1 negative is plus, so it's plus y squared. That's the real part. Then minus 2 it's now minus 4. All right, it's now minus 4 y I, the real part. So I'm going to separate x minus 2 squared plus y squared, then x minus 2 squared plus y squared. Right. So guys, this is the real part that we need to deal with. But according to the question, they say that the real part of the complex number is 0. So if this whole thing is 0, right, show that the locus of the point representing z in the argand plane is a circle with center 0, 0 and radius 2. So now guys, mathematically it doesn't make sense for the denominator to be 0, right? So in order for this to be 0, it means the numerator here should be 0. So this implies that x squared minus 4 plus y squared is equal to 0, right? So here, when we complete this square, it's going to be x, half of this is minus 2 squared minus 4 plus y squared equal to 0. So x minus 2 squared plus y squared is equal to 4, which implies that x minus 2 squared plus y squared is equal to 2 squared. So therefore, this represents the equation of the circle with center 2, 0, and radius is equal to 2. So we have shown what is needed, right? It was very, very easy. So if you know your if you know your calculations very well, we're not going to spend much of the time there, right? We're not going to spend much of the time. It says, no, I think there was a typo error. It's supposed to be center 0, 2, not 0, 0, right? Yeah, it's supposed to be, it was equation of a circle with center 0, 0, radius 2, no, the center was 0, 2, and radius 2. All right. Then from there, okay, because even if I come back here, there is no way the center could be 0, 2. Let me see something, sorry. No. I'm right. They are right. Let me come back here and fix something. I think I did something wrong here. Sorry. Okay, let me fix this part. Right, quickly. The center should be 0, 0. So from this part here, let me do it this way. All right. So from this part, there's no x here. It's just a constant. So I'm supposed to say x squared plus y squared equal to 4. So it's equation of a circle. It's same as x squared plus y squared is equal to 2 squared. So my center is 0, 0, and my radius is 2. Sorry about that. It happens. So if you're a mathematician, you really know that these are computational errors. Sometimes they do okay, right? But we don't expect that. All right. So now we have shown what is needed on part 2. Let's move on to the last part. This is my favorite, which is, okay, so now it's locus in an argand diagram. So we want to shed 2 loci, 3 minus I, right? Less or equal to 4, and pi over 3, then arg z minus 4 minus 2i less or equal to pi over 2. So here guys, just a trick. Whenever you see modulus of something is equal to that, remember it's a circle, it's going to be a circle. And whenever you see arc, it's going to be an arc because it's separated by, it's segmented by angles. It's something that is between pi over 3, 60 and 90 degrees, so it's going to be an arc, right? It's going to be a sector, not arc, a sector actually. Right, so now let's see this one. So if you fix out this one here, it's gonna be z minus 3 plus I is less or equal to, in this case is what? It's 4, right? So this is the equation of a circle. Our center is 3, 1, and our radius is what? Our radius is 4, right? Our radius is 4 there. Okay. Then, if we were to do this, it's gonna be like something like that, right? So my center is 3 for x and 1 for y, right? So it's somewhere there. That's where my center is. So there is one point which you're supposed to show. Since the radius is 4, right? From there to there is 3 units. So here it can stretch up to this point where we can see, we still want to see -1 and 1, right? It's because it's a straight line here. Okay, something of that sort, right? So there is -1 and 1, radius is 4. Then again here, there is a 7, right? So try to show, some symmetry a little bit. Then if you move from 3, going up 4 units, so this was 1 plus 4, so it was 5. So you can think of 5 here. Then here, you can think of -4 there, right? This will guide you to come up with your clear circle, right? Now we have our circle here, right? So less or equal to, it's going to be a continuous, but if it was strictly less, it was going to be a broken circumference. Then you're going to shade anything inside here is required, right? That's the first part for this one. Remember, we need the simultaneous one. Then when we come here, it's gonna be pi over 3 less or equal to arc z minus, so it's negative now, 4 plus 2i, right? Less or equal to pi over 2. So when we are in the arcant plane here, we have our 4 for x and 2 for y, right? That's where my 2 is, right? So it's gonna be this, you put a broken line here. So our first, it's pi over 3, which is 60 degrees. Right, so this is pi over 2. So pi over 2 is 90, so it's a straight line here. And pi over 3, 60 degrees somewhere there. So whatever angle you want, you have to shade in between here, right? And make sure you indicate your angles as pi over 3, and this one is a right angle, right? So now we have to combine these two together, right, to come up with the required solution. So to combine these now, don't overthink. Remember, we had our circle here. Okay. So remember, we had our circle, right? It was 3, 1, 3, 1. It was somewhere there. Then we estimated something there. We put something there, and there, right? So we have our circle here. We have our circle there. This point here is very important, 3, 1. But now we have 4 and 2. So my 4 is somewhere there, right? Then 2 is somewhere there. So they are going to meet here, right? Then I'm going to put that line. So remember, 90 degrees is here and 60 degrees is there. So you can indicate here by saying pi over 3, and I know this is 90 degrees, but the required region now is this one, this shaded part, because it is found in the circle and here as well, right? So guys, that's all we needed to do. Remember, this question had 3 parts. The first part, we needed to solve the equation to find the 4th roots of those complex number, of each complex number. Then on the second part, we were told that the real part for that quotient, where z was a complex number of 0, so we needed to play around with that. Then the last part was on locus. So guys, make sure you keep on practice, right? Do a lot of practice until we get it right. I think we're done.